start chatting away here. So the oil spill question is certainly a great question, and we'll take a look at how AIS data can inform drifting vessels and oil spills here. So really quickly, the nutshell of this project is that we really wanted to understand exactly those questions that just came up. How do we understand the risks that are associated with vessel traffic as they move through the Bering and Chukchi seas? We have recognized this increase of marine traffic that's moving through there. And so we really wanted to get at understanding, and you'll notice that this is literally exactly the same area where Kelly was talking about with the AIS data that she had. It's the same satellite derived AIS information. And so that area study domain is pretty similar. But really we want to get at, let's look at the probability of vessels going adrift, losing power. And then once they start drifting and have lost power, where would they likely drift to? And then if they do go there, what's the likelihood that they'll break up and then put some sort of contaminant like oil onto the coastline? And we wanted to try and estimate that risk to the coastal areas from oil spills. And to do that, the best sort of proxy that we can give is the environmental sensitivity indices. That was the best thing that we had available to us. So this project kind of walked through all of those steps. And if it sounds complicated, it was fantastically complicated. But this kind of breaks it down really, I think pretty simply. There was this large component of inputting data that we needed to get. So all the data we needed to gather, and that's kind of shown here in the blue. And then there was the actual computational component that needed to happen, which is what we see here in the orange. And so if we start kind of on the left and move towards the right in the workflow, we have this AIS data, and really there was a whole component of processing the AIS data just to make sure that we had the vessels and knew where the vessels would be. And then once we knew where vessels were through time, we had to understand where were they going to go. And so that then became a component of the vessel drift simulations. And once they landed on land, wherever that happened to be, then you have this oil spill simulation component of it. And then from there, you went on to looking at, okay, well, once the oil is spilled, what's the actual exposure to that? And then we can estimate the risk, where risk is equal to the exposure times the vulnerability that's associated with that. And feeding into those were the forcings that we would get from both the weather in terms of wind driving forces and your ocean currents as well. And then you had to look at, well, from a windage standpoint. So from a windage standpoint, how is this vessel going to drift? And vessels are all different, cargo vessels versus tankers, et cetera. So there's a lot of complexity that goes into that input data and the computational component, but everything was combined ultimately to try and look at the risk to the shoreline. So if we kind of take a real quick picture of that very first piece of what we were trying to look at, which was really getting at the satellite data and identifying where the vessels were, we could use those positions to start launching the simulations of the drifting vessels. And rather than trying to go in and say, let's take an individual piece, or like every single, like the AIS data is so granular that you really don't want to try and use every single location that a vessel was at any point in time, but rather you want to resample from the AIS information. And so if we kind of look at this graphic, we can say, let's take the information, find those tracks, and then let's resample that into a 25 by 25 kilometer grid, which will give us a reasonable processing point to start with, where we can then take that 25 kilometer by 25 kilometer grid, look at how many vessels were in those grids, were in any individual cell within a grid, and then we could use them as particles and release them from the grid, which allowed us to be able to say if there were, say 5 vessels at any given point in time, and we can send them off to drift and see where they end up going. And that sort of looks like these drift simulations. And in the drift simulation, we would have, effectively what amounts to 52 different sets of simulations, which took every single week from January all the way around to the end of December. And you would run your simulation for 7 days. And if we take a look at the information that's going in, we'd take the ocean currents from HICOM, and we'd take the winds at the the Alaskan 12-kilometer North American model, and those AIS vessel positions launched from the individual grids, put them into the vessel drift simulation, and then run those simulations for 7 days to see where they would ultimately end up landing. And so this analysis, it actually did weekly simulations and then was aggregated to a monthly basis. And in kind of determining how would this simulation kind of move forward, you take about a 2 to 10 degrees variation in the wind. You'd have about a 0 to 60 degree variation in the angle of that wind and the left-right orientation of the vessel, which allowed the particles to be pushed through, both pushed and carried through the water on the currents with the appropriate windage for the vessels. So that's kind of, broadly speaking, how the model in a very non-complex way worked. And that led to sort of this is kind of a picture which is lower resolution than what it is, but essentially you could have a vessel that would start and never hit land, and those could be out anywhere. And then you could have vessels that would start and go and hit land. And actually about 20% of the vessels, it didn't matter what month you looked at, about 20% of the vessels would ultimately ground at some point within the 7 days. And it was particularly true if you were very close to shore. From when your starting point of your grid was close to shore, you would have a very high likelihood of being able to end up and ground on shore. So once the vessels were sent off and grounded in the simulations, then we took all the locations where the vessels ran aground and said, all right, let's start a spill simulation from those locations where we had a grounding. And that simulation from there used effectively like the no model for oil spreading in terms of the status of the oil, whether we had surface oil, submerged oil, stranded oil, evaporated oil. So getting a really good handle on the oil budget and kind of moving forward through the simulation in that manner. And that ended up, again, using the same inputs for ocean currents, the same inputs for wind, except at this point, it was using the vessel drift grounding locations. And so you could end up with your oil kind of moving out to sea, or you could have it move along the coast and continue to oil water. And again, these simulations went weekly, but were then ultimately aggregated up into a monthly basis so that we could understand really kind of a spill volume of, and we had to use a specific oil. So we chose to use marine diesel in this particular case, but the information that sort of guided the parameters of that came from the NOAA ORR oil library. And that ended up, producing an image kind of, or information that if we made it into an image would look something like this, where it's kind of messy and all over the place, but it provided all of the oil spreading locations and the rest of the oil budget that would be associated with whether the oil was on the surface, submerged, stranded, evaporated, etc. So we could take that information and feed it into the risk to the shoreline, which would then give us we could look at the probability of the breach that was derived from that particular data. We could take information from shore zone and use that to compute an estimation of the exposure of that particular shoreline to the oil and then use the environmental sensitivity index to estimate that ultimate risk to the shoreline. And so that was sort of our proxy, that the environmental sensitivity indices were the proxy of the vulnerability to the shoreline of the estimate of risk. So all of those were happy, very, very small numbers. And ultimately we had to think about, okay, now that you have all of these different simulations that were run, how do you actually kind of make sense of all of this data? What does it look like? What kind of information can we actually gather from that? And we were able to begin to create the maps and then the underlying data, if people want to have that underlying data, of the vessel grounding hazards that's associated with the vessel just literally leaving from any given grid point and grounding onto a particular shoreline. The vessel breaching hazard, so once it gets to the shoreline, it's, what's the hazard of it breaking apart? And then the spill hazard associated from that particular vessel that had drifted and then spilled, and then the subsequent risk to the shoreline from that. So all of that information we wanted to make publicly available. And so there is a website that we have set up that really kind of talks about the methodology, literally going into all the details of the methodology about how these calculations for the individual steps actually, the underlying sort of mathematics behind it and the broad methodological processes that we went through to get there. But then also we are working with Axiom and AUSE to get this put up online so that you can actually see the visualization and you can take a look at, what vessel types is it? So because each vessel type had to sort of be simulated kind of separately in order to understand that particular vessel types. And these were broken down into cargo ships, tankers, there's like 4 or 5 categories. I'm trying to remember off the top of my head, but it's like cargo vessels. I believe there's fishing vessels, passenger vessels, and other. So you can look at those for any given month. You can look at the spill risk, the breaching risk, and the hazard associated with them. So there's all 3 of those different types of measurement, and you can break it down by region. So if you want to look at the entire domain of where the modeling took place, you can look at everything for the entire region, or you can look at, what's my risk relative to all the other locations within my geographic response location. And we broke this up because sometimes your relative risk is really important in a given area, and looking at a place like, say, Nome is going to be really different than looking at a place like Unalaska. And so you might want to know your relative risk for that particular area as opposed to that relative risk compared to the entire rest of the state. So we broke it down by geographic response strategy so that you could look at it as a whole, or you could look at it in a much more localized, specific relative risk. And the visualizations that we're working on now are primarily relative risk from low to high, as opposed to putting in the numbers, since the actual numbers on any given calculation is going to be very, very small. It sort of made more intuitive sense to look at it from low to high. So that's kind of the broad picture of what the process itself was and what the project actually came up with. And just as a quick summary, we have estimates that have vulnerability to breached vessels, and then that derived oil spill risk to the Alaskan shoreline. It goes from basically Kayak Island all the way around to the northern Canadian border. We're just sort of missing that Southeast Alaska piece of that. Most of this is online, and we're working the final tweaks that need to be on it for having it completely publicly available on the AUSE website. There were a lot of people that were involved in providing comments and information, as well as sort of vetting the results and taking a look at them to see ultimately what to make sure that we, for the most part, made a reasonable assessment of what that risk actually was. And again, as was mentioned a little bit earlier, the Fish and Wildlife Service was a significant funder of this particular project, as well as the National Park Service. And with that, I guess I'll take any questions. And again, they're really hard. I'll make Jesse answer them, since he was one of the masterminds behind the actual technical implementation of making this all computationally work out. So I do want to send my shout out to Axiom and, again, their data geniuses for being able to process this information and make it work. So with that, I'll go ahead and take any questions.
Anybody have questions for Tahzay and Jesse? Amy's got one. I saw her unmute.
And I guess I should say, before I take any questions, Jesse can correct any errors that I made or misrepresentations, since this was a group effort, and I know Jesse did a ton of those computations.
I would say you nailed it. So job well done, because hearing it from the outside, I'm like, wow, this is incredibly complicated. But you described it pretty aptly.
Thank you.
Maybe just one thing I'll emphasize, and I promise it's not just because I helped with it. That's why these guys let me play with them. Is we did actually have a couple of really cool focus groups that looked at early versions of this and gave us tons of feedback. So that was really neat. I mean, it was, we're on calls with Alaska Shadow, which I think Scott called Alaska Clean Sea. So we had private sector people and public sector people, I think a couple of community representatives. It was just a really neat group of folks that we actually had in 2 different sessions that offered a lot of feedback as it was being developed.
Yeah, we tried to be really, really, really broad about who we had giving us feedback to make sure that the information that we were giving was as valuable as we possibly could. And those sessions were, the Coast Guard was involved with providing feedback and even giving us some of the data that we needed to understand breach hazards and those kinds of things. So it was really great to get quite a broad array of feedback that came back.
I see. Kelly's got a question. Go for it, Kelly.
I won't bore you by grilling Jesse and you on the technicalities of the analysis of the AIS, which is what I really want to do. But I do have a question about, and pardon me if I missed this, but in terms of weather events, because I know Alaska gets some of those giant storms that come through. And I was curious whether you noticed in the weekly analysis, were there particular directions that if a storm comes out of here, any ship here that gets disabled is in trouble, or is it more is that something that could be answered through with this data and these models?
Yeah, so the way we handled that is they were kind of separated, so that we just assumed at every point where a vessel had traversed in the past that a imaginary vessel would drift from there, or 10,000, actually 1,000 simulated vessels would drift from every point that was traversed in the past. It was kind of a Monte Carlo approach, but we did take into account the the parameter space of the ocean and atmospheric conditions by running the simulations over the entire 2019 year. It's kind of limited in scope compared to what some folks recommend, but it's still pretty computationally heavy for the amount that we did. So in some of the results we actually showed that in one of the pictures, there's actually a storm going on. So you could see all of the oil going offshore. And that's because there was just these strong seas going on at that time. So you definitely see the effects if you look at individual simulations.
Yeah, that's awesome. Thank you.
Yep.
I think Amy has a question.
Yeah, hey, you just made me think of something by talking about a storm. So just for future mind-bending thoughts, one of the things that's always neat from our Ocean Prediction Center is, going and seeing where everybody runs to when the big storm is coming. So, we're looking at what happens for just regular, if they're in the traffic lane or the route that they normally take, rather. But where are all these, is there anything that we should be paying attention to in terms of where they go and hide? And the routes maybe to get there, is there a difference worth looking at? That's the question I would have, given how far you've gotten with this. Well done, thanks. Way to go.
Yeah, so we broke it up into 25 by 25 kilometer squares, and those squares would, in theory, include a place of refuge. But yeah, we didn't specifically look at places of refuge as a point to be concerned about within any individual storm. It was very broad. So it's certainly a great question and something to think about as we move forward, or another direction or piece of information that we could derive from this. And I don't know, Jesse, if you have something to say outside of that.
Yeah, I would be curious. I was just thinking that exact same thing. Is the place of refuge, is it going to change the cell in the rasterized AIS data? So I think you would probably want to zoom in and create a finer grained rasterization to kind of track vessels as they do that. Yeah, I don't know, it might be interesting.